Sorption. Sorption. Sometimes the adsorbate dissolves into adsorbent. Initially, the adsorbate appears on the surface of adsorbent and later passes into the body of adsorbent. Thus, adsorption changes into absorption. Simultaneous occurrence of absorption and adsorption is called sorption. Desorption. The process of removing an adsorbed substance from a surface on which it is adsorbed is called desorption. Mechanism of adsorption. The amount of heat evolved when 1 mole of the adsorbate is adsorbed on adsorbent surface is called enthalpy of adsorption. Adsorption is always an exothermic process, and enthalpy change of adsorption is always negative. When adsorbate molecules are adsorbed on the surface of an adsorbent, their freedom of movement becomes restricted and hence entropy decreases. Adsorption is spontaneous. Therefore, at constant temperature and pressure, Gibbs free energy decreases. Delta G is equal to delta H minus T delta S. Types of adsorption. Depending upon the nature of forces existing between adsorbate molecules and adsorbent, the adsorption can be classified into 2 types: physical adsorption and chemical adsorption. Physical adsorption. If the forces of attraction existing between adsorbate and adsorbent are van der Waals forces, the adsorption is called physical adsorption. Since the forces existing between adsorbent and adsorbate are very weak, therefore, this type of adsorption can be easily reversed by heating or by decreasing the pressure. Chemical adsorption. If the forces of attraction existing between adsorbate particles and adsorbent are almost of the same strength as chemical bonds, the adsorption is called chemical adsorption. Since forces of attraction existing between adsorbent and adsorbate are very strong, therefore, this type of adsorption cannot be easily reversed. Comparison between physisorption and chemisorption. The important difference between physisorption and chemisorption are: low enthalpy of physisorption, usually of the order of minus 25 kJ per mole, whereas high enthalpy of chemisorption, usually of the order of minus 200 kJ per mole. In physisorption, forces of attraction are van der Waals forces, whereas in chemisorption, forces of attraction are chemical bond forces. Physisorption usually takes place at low temperature and decreases with increasing temperature, whereas chemisorption takes place at high temperature. Physisorption is reversible, whereas chemisorption is irreversible. Physisorption is related to the ease of liquefaction of the gas, whereas in chemisorption, the extent of adsorption is generally not related to liquefaction of the gas. Physisorption usually forms multimolecular layers on the adsorbent, whereas chemisorption usually forms monomolecular layers on the adsorbent. Physisorption does not require any activation energy, whereas chemisorption requires activation energy. Adsorption isotherm. The variation in the amount of gas adsorbed by the adsorbent with pressure at constant temperature can be expressed by a curve termed as adsorption isotherm. At low pressure, the graph is nearly straight and sloping. Hence, the extent of adsorption x upon m is directly proportional to the pressure of the gas. This can be expressed as x upon m is directly proportional to P raised to the power 1. At high pressure, saturation of the adsorbent surface occurs, and then amount of adsorption does not depend upon the pressure of the gas. This can be expressed as X upon M is directly proportional to P raised to the power 0. Freundlich isotherm. In the intermediate range of pressure, X upon M will depend upon P raised to the powers between unity and 0. This can be expressed as X upon M is directly proportional to P raised to the power 1 to 0, or X upon M is directly proportional to P raised to the power 1 upon N, where value of N is greater than 1, or it can be written as X upon M is equal to K multiplied by P raised to the power 1 upon N. K and N are constant, whose value depends upon the nature of gas and the adsorbent solid at a particular temperature. Taking logarithm on both sides, we get log X upon M is equal to log K plus 1 upon N log P. The graph between log X upon M and log P is a straight line. The slope of the line is equal to 1 upon N, and the intercept on log X upon M axis will correspond to log K.